Okay, now we are on exam questions of exponential sequence. So the first question here, we are given the nth term of a sequence is 100 times 1 over 3 raised to the power n. We now ask how many terms are greater than 1. How many terms are greater than? It's very simple. What we have to do, they told us that the nth term is 100 1 over 3 n. So we use this to get remember the nth term now is just a formula. So we use it to get the other term. So term 1 is now when n is 1. We have 100 1 over 3 raised to the power 1, which is 100 over 3. And as you can see, it's greater than 1. So let's check another term. Let's check term 2. Term 2 is 100 1 over 3 squared, which is now 100 over 9. I think it's greater than 1 also. So let's check term 3, which is 100 1 over 3 raised to the power 3, which is 100 over 27, which is also greater than 1. So let's check 4, which is 100 1 over 3 raised to the power 4. This is 100 over 81, which is also greater than 1. So let's check term 5. So we have 100 1 over 3 raised to the power 5. I think this is 100 over 243. So I think this is less than 1. So how many terms are greater? We have 4. The answer is 4. So 4 terms are greater than 1. So it's just a simple question, it's just logic. So the second question, if 3 minus x, 6, 7 minus 5 are consecutive terms of a geometric progression with r, the common ratio, less than 0, we have to find the fourth term. All we know that for any geometric sequence that the common ratio is always that's the term n over term n minus 1. So that's our formula for that. So which implies that what we have here is now 6 over 3 minus x, or 7 minus 5x over 6. Because they always result to the common ratio. So they are equal. So we'll have a very nice equation. So let's cross. So 6 times this is 36. Why this 3 minus x times 7 minus 5x. So we have 36 equals this minus 7x minus 15x. Minus 7 minus 15 is minus 22. So I have 21 minus 22x plus 5x squared. You get this minus 7x minus 15x. Minus 7 minus 15 is minus 22. So why this times that? So that is what we have. So the next thing is since we are forming a quadratic equation here, so we have 5x squared minus 22x. So I'm moving this, so that this should be minus 15 equal to 0. So I moved everything to the right hand side. So we are looking for 2 terms that will multiply to. So there is a shorter unit. Remember the formula I told you. Let's take 5x for quadratics. 2 terms that will multiply to give me 5x squared is 5x and x. Y 15 is minus 5 and 3. So if I write minus 5 and 3 here, I think there is a, so let me make it minus 15 minus 5 here. Y here is plus 3. Do you get? Because if I do 5x times minus 5, I have minus 25. Minus 25 plus 3 is minus 22. So the term I've factorized is this and this. 5x plus 3 and x minus 5. So equal to 0, equal to 0. That's the factor term now. The product of this, for it to be 0, each of them will be 0. That's any of them could be 0, but we don't know the one. So either the first or the second. Therefore, x is 5 or minus 3 over 5. So, but they told us that the common ratio is less than 0. So if I put 5 here, if I put 5, okay, let's test. So let's test. When x is 5, so we have 6 over 3 minus 5 is now minus this minus 3, so which is less than 0. So I think that's what we use when x, the other one will turn to be positive. Okay, let's check before we conclude. So but when x is minus 3 over 5, I think that's it. So we have 3 minus 3 over 5. I think this will turn to positive, to be greater than 0. So we take our therefore our r is minus 3. Our r is minus 3. So we are asked to find the fourth term. Remember, the fourth term of any geometric progression is ar raised to power 3. Ar. Okay, our first term is now 3 minus x, which is 3 minus 5. And our common ratio is minus 3. So minus 3 raised to power 3. So I have minus 2 times minus 27. So the answer is 54. So our fourth term is 54. The next one, we are given a geometric progression. It has a first term of 4a and each seventh term 1024. Another geometric progression GP has first term 3a and each sixth term 192. We have to find the sum of the first 4 terms of this. So the first, so for GP1, the first term is 4a, the seventh term is 1024. But we know that the seventh term is always ar raised to power. The first term, let me not use. Is always T1. Let me use T1 as the first term. Raised to power 6 equals 1024. And T1 is 4a. So I have 4a r raised to power 6 equals 1024. I think 4 can go. So dividing both sides by 4. So we'll have a r raised to power 6, 256. So that's what we have. So a raised, let's call it equation 1. So the next one for GP2, they told us that the first term is 3a and the sixth term is 192. So we know that the sixth term is T1 r raised to power 5. Yes, from the formula for the nth term. And we know that this is 3a r raised to power 5 equals 192. So dividing both sides by 3, we have a r raised to power 5 equals 64. So this is equation 2. So I will divide equation 1 by 2. So if I do equation 1 divided by equation 2, I have ar6 over ar5, which is 256 over 64. So which implies that AA. So we have one R here. So 256 over that. I think 8 in that is 32. 8 in this is 8. So I think it should be 4. So it's 4. So for any GP, the sum of the first n term is always term 1 times Rn minus 1 over R minus 1. So for GP2, we are asked to find the sum of the first 4 terms. And what we have here is 3a. Do you remember? That's our y here is 4 minus 1. 4 minus 1. So what we have here is now 3. So we have a. Okay, this should be 4 because our R is 4. So we have 3. So we have a 3 raised to power 4 is 81. Sorry, 4 raised to power 4 is 2. I think 256 minus 1. So we have 255a. So the next thing is to find the value of a. So the value of a is from any of the equation, from equation 2. A is 164 over R raised to power 5. 64 over R raised to power 5. And we know our R is 4. So we have 4 raised to power 5. So I think I have this 64. This should be 4 3 times 4 2. So we have 1 over 16. Our A is 1 over 16. Therefore, the sum of the first 4 term is now 255 times 1 over 16. So the answer is 255 over 16. So that's the answer.